Okay, so after talking about the different kinds of malware, we'll start talking about authentication. لأنه the fundamental way to protect any computer system, and the first thing is you need to know who is that person that is connecting to this system, right? And at the end, if you cannot know the identity of this person, it doesn't matter. Everyone have the same permission, and if everyone has the same permission, it might be the attacker who starts to take those permissions. So when you want to authenticate yourself as a user, you can do that in one of four ways. It's either something you know, which can be your account name, your password, your passcode, your passphrase, whatever that is. Or it could be something you have, a smart card, it might be a device that gives you a one-time pad numbers, it might be something that you plug in your USB, or it could be something you are, your iris scan, your fingerprint, your palm print, your face print, whatever that is, it's something that defines you as a person. Or the fourth one is that it is somewhere you are. Sometimes, like, that you say you can only access this data if you are inside the organization network. If you're outside the organization network and you're not physically in the organization, I'm not going to give you access. So it's always one of those four things or more. So you can ask for, like, Apple iPhones, they sometimes ask you for the passcode, and as well they ask you for your face. It depends. You might be asking for multiple things together. When we talk about authentication, there is another concept called verification, right? So in authentication, I can do one of two things. I either verify your identity, أتحقق من هويتك, or I identify you بمعنى أبحث عن هويتك. If I want to verify your identity, it's simply انك انت تقول like, I am this guy, this is my username, this is my account, and here is the proof, here is the password, the fingerprint, whatever that is, that I am this guy. So always, like, when you give your username and password, you're claiming some identity. You're saying, I am this person who owns this identity. Identification, on the other hand, you don't claim an identity. And this is, for example, when you do some forensics and police forensics, they have fingerprints. They want to know which those fingerprints belongs to who. So they use that fingerprint and search throughout the whole database of every possible fingerprint and find the closest one. In verification, there are only two answers. It's either you have the secrets associated with this identity or no. So you either authenticated or not authenticated. In identification, sometimes you don't have one answer. You have a probability to rely. أقرب fingerprint to this fingerprint is this one, and they have 95% similarities, right? Sometimes you have 100% similarities, sometimes you don't. But there is a difference between the two, and you need to know in your system what you're looking for and what you're trying to do. So as I said, there are multiple ways, and everything that we do in computer systems that we always use authentication. Logging into your local computer, logging into your phone, logging into the server, accessing some websites, accessing some accounts. Everything involves, whenever we need to protect some things in it, it involves some sort of authentication. And there are multiple vulnerabilities that we need to consider. الأولى, what if the channel between the client and the server is compromised? اللينك اللي بين client and server, anyone can sniff the username and password. Or what if the server is compromised, where someone can steal the list of username and passwords? Or what if the client is compromised? بمعنى we have a keylogger at the client, and if you type in your username and password, someone can steal it. There is the whole concept of social engineering. بمعنى like someone calls you or phishing attacks or someone tries to get that information from you somehow. They tell you what's your, they call you, say, hey, we're from this organization. احنا من الجهة هذه we're doing some support and assessment. What's your username and password, or what's your bank pin number, or مثلا you want a prize, عطنا رقم حسابك ورقم الحساب علشان we send you the winning prize, or tons of things. Or sometimes you could use a weak password. The most common password في العالم اليوم, every year it wins to be the best and most common password في العالم is 123456. The most common password في العالم. People use it all the time. And if someone has this, their password, anyone can easily get it. There are multiple threats to passwords. الأولى offline dictionary attack. بمعنى someone steals the whole list of username and passwords from the server, from your computer, and then they start offline with that list, tries to recover back your passwords. And we'll take more examples how this can be done. Or online guessing. تفضل.
معلش بس عندي سؤال في السلايد اللي قبل. الشانل اللي بين الكلاينت والسيرفر وش المثال اللي عليها؟
مثل انت فاتح www.gmail.com والموقع مثلا ما هو under HTTPS, right? So انت you're typing your username and password and sending it. في اي واحد جالس مثلا في الواي فاي نتورك اللي انت فيها, they see the username and password in the clear. Anyone at the gateway, anyone in the ISP مثلا شركات اتصالات, anyone in the middle can see everything that you type.
هي اللي man in middle attack.
It is the man in the middle attack, yes. تمام؟
واضح ممتاز.
طيب, we'll get back to offline dictionary attack soon when we take more examples. Online guessing attack بمعنى واحد يروح you know, مثلا in ATM, they put your card بعدين يجرب الرقم الأول, الرقم الثاني, الرقم الثالث, الرقم الرابع لمين يطيح على الرقم الصح. أو you have your account at this server and I know your email and I try your email and then I try password 1, password 2, password 3, password 4, and I do online guessing all the time. Another threat to password is logging spoofing, and this is what is commonly known as phishing. أنا أرسل لك رسالة نصية أو email, I tell you, oh, like I am your bank, الراجحي bank, you need to update your information urgently or your bank account will be locked. You have a link. A link, it doesn't look, it looks like the Rajhi Bank. You don't know. They put the logo, they put everything. تضغط على اللينك. You go to a website. It looks like the Rajhi Bank website. They cloned it exactly the same. You put in your username and you put in your password. What happened? And you got some login spoofing. The fourth type is shoulder surfing. انت جالس in a coffee shop and you're typing and someone is looking there, or there is a CCTV camera or somewhere that starts to point to your keyboard and see what do you type, your username and your password. آخر شيء تكلمنا عنها قبل شوي is like the social engineering, where I can call you and say أنا من البنك أو من شركة X أو شركة Y أو شركة Z, أو أنا مديرك في العمل, نسيت الباسورد حقي, سوي لي ريست وعطني اياه. Whatever can be done is somewhat a social engineering. We'll go through, and this is to explain as well how offline dictionary attacks work, how passwords are stored in Unix, Linux systems in general. So first of all, قديما in the old Linux, the file etc password stores the username account. Like, let's say someone has a username ABC, and then they have a password. So what the system does is actually stores ABC and the hash of your password in the system. Right. So let's just a second. Okay, so if your account is A, B, C, so this is what gets stored in this file and the hash of your password. When you want to log in later, you come and you say, hey, Anna, my username is A, B, C, and this is my password. The system takes this, does the hash of this password, and then check. And then take this first. You go, okay, this is ABC. I'll check this. I'll do this hash. If those two are equal, معناها the password is correct. If those two are not equal, معناها the password is incorrect. This file was readable by everyone. Right? Less readable by everyone because any person can update their password. And any person can see the list here and they're able to update their passwords. In new Unix saves the hash of the password, but not in the etc password. They save it as something called the etc shadow. And the etc shadow is only readable by the root. They also change how you store this, and we will talk about this in a little bit. بس السؤال الحين how can an attacker who has access to this file, etc password, how can they brute force and try to find the password of the user? What can they do? هاي شباب، أحد عنده إضافة أو an idea of what they can do?
يدخل على اساس انه الروت.
لا، هو عنده الفايل، خلينا نقول واحد حصل الفايل هذا فيه يوزر نيم 1.
راح يطلع الباسوردز حقتهم ولا
كيف يطلع الباسورد؟
بس اللي نعرفه اذا كان هو از روت لان تحته اليوزرز يقدر يطلع الباسورد.
كيف؟
Technically, I don't know.
Can the root access الباسورد حق اليوزرز؟
ممكن دكتور ما يقدر، لأن في فانكشن رياضيا تسمى one way function، لها طريق ينقلها من A إلى B، لكن من B إلى A غير موجود.
Exactly. This is a one-way function. This is a hash. This is the example that we took بداية the class. We said it's a one-way function. We'll take X and give you a hash of X. But you cannot get the reverse. And this is a secure hash. We're using a secure hash here.
بمعنى دكتور ان الروت ما يقدر يدخل على الباسوردز او يغيرها حقت اليوزرز.
خلني من الروت، انا اقول attacker
اوكي
had this file. Okay. كيف الاتاكر ممكن يعرف الباسورد حق user 1 and user 2 all the way to user X? What would the attacker do?
ممكن يقارن الداتا الموجوده، حاجات الكومن باسوردز، يعرف ان مثلا هذا 1 2 3 4 الى 6 مثلا، يعرف ان هذا الهاش حقه، ويبدا يقارن، يعرف ان هذا معناته كذا وهذا كذا، فيبدا يفهم.
كيف يقارن؟
ما ادري، بس انا قد قريت عنها، ما ادري اذا هي نفس المثال او لا. يكون مثلا A معناته 12، B معناته 13 وكذا.
ما فهمت، ممكن توضح لي زياده؟
هو الان مسوي هاشينج ويبغى الموجود عنده في الملف هاش، ويبغى العكس، يبغى اللي هو الباسورد كامل.
صح.
عنده الان الداتا كامله، يحاول يحللها، ياخذ كل باسورد ويقارنه باللي قبل، يعني يشوف وش المتكرر منها. فمثلا
طيب اذا حصل two hashes that have the same value
بالضبط،
بس بيعرف ان هذول الباسوردز الاثنين زي بعض بس ما يدري وش،
بس يعرف انها من الباسوردات المتكرره، يعني مثل من 1 إلى 6 مثلا.
مو شرط، هو يعرف انه اثنين يستخدمون نفس الباسورد بس هو ما يدري انه if this is easy password or common password or not common password. طيب, so if the attacker has a list, right, a dictionary of like the most common مثلا 6 million passwords, حلو, عنده 6 مليون different most common password في العالم, يجرب الباسورد الأول and hash it ويقارن, right, is this hash equal to this hash, الثاني الثالث الرابع الخامس العاشر all the way, right. Then what happens, you know, at some point they will find the, yeah, they might, there's a high probability, you know, they might find something that has an equal hash, and the attacker can even more intelligently, لأنه هذا الحين بياخذ order of n, right, every step he needs to hash the password وبيقارن hash and بيقارن hash and بيقارن. A smart attacker can actually do this in an order of log n, which takes significantly lower time. يجي يقول لك خلاص أنا عندي password 1 وهاش 1, password 2 وهاش 2. أنا وش بسوي؟ I will order هذه results الhashes, I will order them from the smallest to the biggest, right? Just because those at the end are some bits and I can have them in a number representation. بعدين I will actually use binary search. أبجي okay أنا I'll try هنا very quickly, right, أخذ هذا this hash, right, and I see لما يجي الهاش هنا, is this hash larger or smaller than the hashes? If it's smaller, طيب, and I do binary search لمين أقع على the thing that is the closest. إذا هم match معناها هذا هو الباسورد because they matched. If they don't match معناها the user is using here a password that is not in my dictionary. فأنا يعني now it's almost as an attacker game over, right? But now in actually login time, I was able to crack the password of the user by simply doing a comparison of this hash with all the hashes that I prepared before. السؤال اليوم اوكي طيب انا اذا هو order of n, this is brute force, انا ما عندي مشكله. If he's gonna do brute force for every possible hash, الله يقويه. Like I cannot prevent this. Anyone in the world can do this. You can do a brute force على every possible key. You can do brute force. Like brute force always going to happen. بس أنا ما أبغاه ياخذ something better than brute force, like an order log of n, because that would make me immediately vulnerable. So how do we fix this? Well, we fix this by changing the way that we hash into the following format. Instead of just hashing the password, instead of just doing h password, we actually, for every user, we create a randomly generated number, right? The user يجي the first time يخزن his password or update his password, give him username واحد, r, right? And then r I generate it at random, and then hash of the password مع r. Okay, so I do this. The thing is now لو نرجع مثالنا اللي قبل, someone has this list of password 1 and hash of this password 1, password 2 and الهاش حقها, password 3 and الهاش حقها. If someone takes this hash right now, this is no longer the hash of the password only. It's the hash of the password and the R. So for this particular user now, I cannot do binary search anymore. I have to, لأنه أنا ما أعرف الR قبل, every user have their own R. وإذا أنا بسوي بدال التيب معناها for every R I need to do a table, right? وبضيف R هنا, فبيصير عندي table like the following: P, R, and the hash of P and R. Okay? And if R, let's say if R is like 24 bits, معناها for every password I need 200 of the 2 to the 24 different R's عشان أحسب وأسوي binary search, which makes it insanely large and unfeasible. So الحين بالحالة هذه معناها now the attacker will have to go to the order of N. They have to take P, put the R, and then hash. بعدين check if it's matches. No match, take the other P, put the R, and then hash. Check the match. No one, خلاص, I no longer can do the binary search and optimize the time. And this is basically how, what is a dictionary attack. في حالتنا احنا قبل شوي الجدول هذاك الكبير, this is what is called the dictionary. And you can do it offline, try every possible password, 6 million different passwords, it doesn't matter. You can do it and do the dictionary attack. If we add اليوم computer systems, all of them add the R. And they say now with the R, I prevent prepared online dictionary attacks. معناها الواحد لازم يسوي a brute force using the dictionary or whatever they want. They need to try the different possibilities one by one. So this is if it's offline. بمعنى the attacker stole that list. What if the attacker does not steal the list, لكن they can do online? And this is the most common thing that we see اليوم. When you try many times, if you have different failed attempts, the account get disabled. أو أحيانا في الجوال إذا جربت 10 مرات يقول لك انتظر دقيقة, بعدين انتظر 10 دقائق, بعدين انتظر ساعة, بعدين انتظر 4 ساعات, بعدين. ليش؟ عشان هو يقول لك أنا أبغاك مع الوقت ما يصير عندك وقت تجرب all the possibilities. Right? لأنه then you can do it على راحتك و you will reach the correct one. But what I want you to do is after you try a certain number of possibilities, I either delay you for some time or I completely disable the account. The normal user needs to call us in and check and unlock their account, and we do a new set of process of authorization. نتكلمنا عن weak password and why people use weak passwords. There are multiple ways to fix against these weak passwords. الأولى is that you allow passphrase. اليوم someone can have a password called مثلا Zoom, okay, because we're talking over Zoom right now. Horse, then واحد يحب الhorses, right? Frog, right? Microsoft. If you look at this is a really long password. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 different characters, right? and in the mind of the user بيتذكرها، لأنه هو خلاص لما يجي to come and log into Zoom هو يقول okay like Zoom, horse, frog, Microsoft, and he will always remember it. And for someone to guess, not only they need to guess the 4 words, but also the order of the words makes a difference. Right? Like إذا هو اختار the same words بس حط horse قبل Zoom, that doesn't work. And the user can also add one level of sophistication. هنا يجي يقول okay, horse بدال الأو أبى أحط 0. Right? الاس بدال الاس أبى أحط $sign. It's still the same easy thing to remember, and I'm only changing for every O, I'm changing a 0, and for every S, I'm making it a $sign. So it becomes a lot more sophisticated. Another example to address the issue of weak passwords is to use randomly generated passwords to تستخدم password manager. Whether you're using iOS keychain, you're using tools like 1Password, LastPass, or and many, you can do that. The third thing that you can do is actually start to create some rules. And look, وهذا اللي دائما نشوفها uppercase, lowercase, كذا 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 كذا. And also the other thing, you can run dictionary tools. اليوم in the market يقول لك the list of dictionary passwords, or the most possible passwords, or passwords that we usually use for brute force. Either a customer our user account is actually in this dictionary and you check it during the registration, well, no, I'm sorry, you gotta choose a new password. And the rules sometimes doesn't actually do the best job, then the users are really good at escaping the rules. And there are multiple ways to create a good password. يعني هذه مثلا one algorithm that is very interesting, right? So you can create a sentence like this: at 12 noon, I am hungry. And then your password becomes like this quotation mark, letter I in capital, and then this apostrophe, يعني اللي هي هذه, right? This thing. And then the letter S in capital, then number 12, then and changes into and, I becomes capital I, A, whatever. But this becomes almost looking like a very complex and random password. But for عقل user, it's actually an easy to remember statement. Many security professionals يقول لك يا أخي also make the user do some password expiration. I'm a big believer, and many experts in the cybersecurity will like, this is the worst thing that you can do. Why? 2 reasons. If the user chose a good password, until now, after he remembered the password, it was like something like this, or like this, very complex, very hard to guess, and he remembered it. After 90 days, it didn't expire, it didn't like انت جاي تقول اليوم راح اغيرها. The user will tell you why. It's a good password. Why are you telling me to change it? And if it's a bad password, it's already horrible. The bad password should not even last for 1 minute, let alone 90 days. So the bad password should already be changed من زمان. So then what are you trying to do by mandating password expiration? If it's a bad password, do it قبل and fix it. If it's a good password, why are you asking the users to change it? عشان كذا تلاحظون انك احيانا في بعض الاورجنايزيشن يجي يقول لك oh your password has expired, change it. But if you look at something like Google will never tell you change your password, right? Your bank, most of the banks will never tell you change your password. لأنه يقول لك if you chose a correct password يا أخي خلاص I'm good انك انت حفظتها ولا تنساها ولا whatever. And if you chose a weak password, I should have not even allowed this in the first stage. And every time when you want to make passwords stronger, remember there is usability problem. انت ممكن تحط لهم اعقد rules في العالم، بس هم وش بيسوون؟ بيكتبونها on a sticky note وبيعلقها على الشاشة أو in his office أو بيكتبها in the notes app in his phone. فأنت اليوم لأنك ضغطت عليه بالأسلوب الغلط, you caused him to have another unprofessional and unhealthy behavior, and a behavior that could cause him to have some vulnerabilities. So always there are usability issues and challenges and problems on this. Right? One of the notions in authentication is something called a trusted path. Trusted path, مثلا, when you want to come and log in the Windows machine, لازم أحيانا you put Control-Alt-Delete. Control-Alt-Delete is like a trigger in the computer, and the only software that is able to respond to that trigger, it's in the design of the operating system, is the login screen. فإذا someone trying to create a fake screen, like بحيث إنه like someone may be in the lab, so with a screen that looks exactly the same like a login screen, ويحطها لك as a background in his own account. أنت تيجي تدخل, you think that's the login screen, and you immediately tap your username and password, you click sign in, فهو وش يسوي automatically save this, sign out, you go like, oh sorry, an error, sign in again. And people all the time, they type their password, بعدين يجيهم error, يقول شكلي أخطيت. And but before you sign in, if you click Control-Alt-Delete, everything will go out, and then the logging screen will be the only thing that comes in. If you're not logged in, if you're logged in, the thing that comes out is the control in the Windows. Always, many people have tried to do this in the web. هو يقول لك أنت فاتح ويب سايت. I wish that we have a trusted path. إنك إذا تضغط 3 أشياء, إنه any fake or phishing website will never be able to respond to it. And so far, no one has successfully managed to do a trusted path in the web. And this is why phishing continues to be one of the biggest problems in security. يعني SANS, which is one of the very well-known institutes for cybersecurity, يقول لك 95% of the attacks start by having a successful phishing attack. On average, one phishing attack cost the company over $1.6 million to recover from it. And there are multiple kinds of phishing. There is phishing, the normal phishing اللي كلنا يجينا. There is spear phishing, which is phishing that is targeted to you. يعني مثلا اليوم واحد منكم, they could be targeted. And then the people know إنه يدرس في جامعة الملك سعود, he's taking security class, and then they send him a very targeted phishing email saying, oh, like بناء على دراسة أو سيرفي قاعدين نسويه في مادة السكيورتي جامعة الملك سعود, وكونك أحد الطلاب اضغط هنا وعطنا بيانات رقمك الجامعي وحسابك الجامعي والباسورد حق الاكونت حقك في الجامعة. Okay? So this is very targeted, and it might look super real لأنه it has information very specific to you. Whaling is exactly like spear phishing. The difference is that it targets the people who are very high value. يعني someone like مدير البنك, right? رئيس تنفيذي للبنك, رئيس تنفيذي للشركة. ليش؟ لأنه if I get the attack of those people, I can do far more damage than an attack of a normal employee. And we always see phishing. That's an example, right? Looks very nice, very neat, and it scares you. Oh, your password will expire. Click on this link. And you look at this link, the text looks like a normal link, but if you look at the hyperlink behind the text, it actually looks absolutely fake. So how do you basically, okay, what do you do with passwords? If it's, text passwords have existed for ages, so what you can do with it? One solution is geographical passwords. مثل many Android machines, for example, where like multiple dots and you just connect the dots together. Another is something called keystrokes. بمعنى, I don't only look at your password, but how fast you type the password, and how hard you clicked on the keyboard. لأنه those things are very unique and different. Or I could go beyond password مثل two-factor authentication. اليوم قاعدين نشوف every organization and bank does a two-factor authentication. يقول ما يكفي تعطيني الباسورد بس، أعطني الباسورد and as well I'll send you a one-time number to your phone, give me that. Or biometrics, maybe give me your password and your fingerprint, give me your password and your face. Or security tokens, give me your password and I want you to plug in this USB stick, for example. So you could do many things beyond just simply the password that exists. There is that notion of a one-time password. One-time password is that it's a password that is used only once. اللي ضربنا فيه مثال قبل شوي, when you have a two-factor authentication, until you have your password that you use every time, but also you have a one-time thing that comes and you can log in once. في organizations اليوم تروح لهم, you don't give them username and password, you just give them your email, which is your username. They send you a one-time number, and then you take that number, it becomes your password. Every time they send you that one number, and if someone steals that number, it's useless because the number only works once. So if someone behind you trying to steal your password, that remember it or have the sticky note, or if you use your password, khalas, no one is going to be able to use it again unless they use it faster than you using it. Challenge response مثل ما شفنا قبل في شو اسمه نيدم شرودر إذا تذكرون, where I send you something, right? You reply back encrypting that thing. We saw it when we were talking about cryptography. You know, like I send you a nonce, you reply back by encrypting that nonce. So I said, like, there is no, you're not sending me a secret. You're not sending me the key. You don't have to send me the key, but you basically, I send you something, I challenge you, and you encrypt that thing, hash that thing, do a map, not hash, do a map of that thing and send it back. Then I know that you have the right secret. Zero knowledge proof are actually algorithms where I can, without doing a challenge response, I can prove to you mathematically that I know a certain secret without telling you what that secret is. We're not going to get into this in this class, but it's a very, very interesting mathematics that basically I can prove to you using mathematics that I know the secret without sharing the secret with you. And if you Google zero knowledge proof, you will find many, many examples in the internet. So going to one-time password, there are a couple of examples. مثل ما قلنا, like time synchronized, which means like يعني مثلا أنا عندي device. Like if any of you uses, for example, Google Authenticator in their phone, you give it a secret, right? And then that secret also exists in the server. A server لما تيجي to use Google Authenticator يقول لك scan this QR. This QR has a seed, and then every time كل دقيقة the Google Authenticator app or the Authenticator app will give you a new password, and then you can use this to log in every minute. If you miss, then it gives you another one, and also like the computer server itself also has the same seed, and it can check, did I get the right thing or not? The other thing لما تشوفون لما تفعل one time عفوا two factor authentication مثلا in Google, in Twitter, in many organizations, يقول لك هذه offline backup list. ليش؟ If you lost your phone or lost your number or you can't open your phone, there is a way to access with this list, and this list can be used, like every number can be used once. You print it, تحطه على جنب, you save it. If you lose your number, you cannot log in using your normal password, لأنه it will ask you for the two-factor and the second factor, and you don't have your phone anymore, right? So what this is giving you the ability to recover by having this one-time short list of passwords, for example, to be used. A third way of one-time passwords is called Lambert. And Lambert has a very, very interesting algorithm. So Lambert يقول لك okay نتفق أنا وياك client and server one time. We select the secret value W, right? And then we have a hash function that everyone knows it. And then we have the number T. The number T is the number of times that we want to log in. So let's say مثلا we want to log in. I want to use this في البداية to give you the ability to do 1,000 logins, right? طيب بعدين I compute W0. W0 هو إني أسوي هاش ال W T times 1000 مرة. فأنا أسوي هاش W بعدين أسوي هاش للنتيجة بعدين أسوي هاش للنتيجة and I do this like 1,000 times. للنتيجة. And this will become my W0, right? And then هذه what the client does. The client ما يعلم السيرفر W, ما يعلم السيرفر أي شيء، بس يقول له أنا I will use this hash وبس. حلو؟ الكلاينت أليس يرسل للسيرفر W0, which is this hash 1000 مرة, right, for this W value. طيب the client now A wants to authenticate. But what does A does? A always have and save the number I. I في البداية يبدأ من 1. أنا the first login وش أسوي؟ The first login I do and compute the following. So I is actually 1. بعدين I compute H T minus 1 T 1000 يعني 999 ال W. حلو؟ So هو بيصير عنده الفاليو اللي هنا 999 هاش ال W. وبرسل هذه WI اللي هي W1 أبرسلها للسيرفر. السيرفر ياخذ W1 بكل بساطة. This hash of 999 if I hash it one more time تعطيني الهاش رقم 1000 اللي هو W0 وأنا عندي W0. فوش أسوي؟ right? I hash this new value that I got, right? And if it's equal to the hash that I had before, then it's perfect. I allow the user to log in. If it's
يعني ما يحتاج أجرب 1000 مرة بس
ما أحتاج أجرب مرة، أجرب مرة واحدة. أنا السيرفر وصل لي الهاش هذا هاش 999 W، أخذه أسوي one more hash. إيش بيطلع؟ بيطلع هاش 1000 وأنا W0 اليوم عندي هي حقيقة هاش 1000. بعدين أجي أقول خلاص ممتاز ألغي W0 وأحتفظ بالW الجديدة اللي عندي. اليوزر بيجي لوجن للمرة الثانية login number 2 فبيحسب ايش؟ H 1000 minus 2 اللي هو 998 ال W وبيرسلها للسيرفر. هذه becomes W2. يرسل W2 للسيرفر، يوصل السيرفر W2 يسوي له هاش مرة واحدة فبيطلع هاش حقه 999. وبقارن هل هذا الهاش يساوي آخر W عندي اللي هو W1 لأني أنا خلاص W0 ما أحتاجه. إذا يساوي perfect معناه this user knows this. طبعا السيرفر ما يعرف W، ما يعرف this. أنا I never had to send this. ما أحتاج أرسل هذا السيرفر. السيرفر بس أرسل له W0 وهو ما يحسب من الكلاينت only starts calculating from the beginning. بعدين إذا خلصت وسويت لوجين المرة 1000 أبى أسوي هاش 0 يعني مرة واحدة right الW وبرسلها للسيرفر. السيرفر بيسوي لها هاش وبتطلع عندي the hash number 1 وخلاص. ف this is how I basically use Lambert. الأكبر مشكلة في لامبورت إنه إذا مرة واحدة أنا أرسلت W1 وما وصلت للسيرفر، جاء واحد أتاكر in the middle وألغاها، ما سمعت شيء من السيرفر، ما أدري وش وصل للسيرفر، السيرفر انتظر وقال لي error. فالمرة الثانية أنا أكيد ماني مستخدم W1، أبى أستخدم W2. لما استخدم W2 السيرفر بيجي هو ما وصلته W1 فهو بيسوي هاش مرة واحدة، فبيطلع عنده ال W2 هذا الهاش. طبعا هذا الهاش ما يساوي W0 فبيقول لي لا incorrect login. فلما يقول لي incorrect login أبى أسوي login W3 ثاني مرة وهو بيحسب and we will exhaust كل ال1000 W هذه will never login. ف the problem with Lambert إنه دائما it has to be synchronized all the time. Anytime I lose that synchronization, it's done. It's game over. I have to restart from the beginning. Challenge response تكلمنا عنها بس these are some other examples as well. So إذا أنا والuser مثلا we have the secret key, right? أقدر أجي وأقول أنا I'm A, I want to log in myself to B. أقول لك okay يا B بيني وبينك secret. I'll do the MAC للوقت الحالي time stamp الوقت الحين وأنا أبغى to log in to you as B. B يوصله هذا. He doesn't know what is inside this. The MAC is like a hash. تذكرون لما طبقنا الماك بالهاش. فهو يحسب بسرعة MAC K T B and يحط الايدنتيتي حقته and he will check. If those two are equal يقول لك okay perfect أكيد اللي سواها يعرف السيكرت كي and I let him log in. طبعا ممكن يقول اوكي ليش نستخدم التايم والتايم مشكله وما ادري ايش، انا ممكن احسبه الكلوك في الجهاز حقتي مختلفه الجهاز حقك ويارا يارا يارا. So then we basically use challenge response. اجي اقول لك اوكي انت A you come and knock on my door and say hey I want to log in. B يرسل لك RB انت تيجي تقول okay I'll do the MAC using the key of RB وارسل لك this back. And then the B does the MAC again, right? Okay, RB اللي هو أرسلها and he puts his own identity. If those are equal معناها perfect. The sender knows K. وأحيانا إذا A يبغى authenticate himself to B and B authenticate himself to A لازم we do it both ways. So A يجي يطق الباب على B I want to authenticate. B يقول okay here is this and then A يقول okay thank you so much here is mine. And I will do this. I'll include mine, yours, and your identity. B يقول okay خلاص أنا لما سويت this again I received this, right? With the key. And I received the RA منك. I sent you the RB before, so I put the RB. And I'll put my identity as B. If those two are equal, perfect. Log in. بعدين اجي اقول اوكي if they're equal perfect معناها A انت اثبت نفسك لي. انا now B I want to authenticate myself to you. I'll do this MAC. I will include mine and then yours. Any attacker who doesn't have K they will never be able to replicate those messages حتى لو هم يعرفون RB and RA لانه they don't have basically the key. So دائما وهذه دائما تمر عليكم anytime you look and build a system that requires password you have to ask what is the attack that you're trying to stop. Is it targeting certain accounts انه الاتاكر لازم ياخذ الادمن اذا ما اخذ الادمن ما يفرق or attacker can succeed اذا دخل على اي account in the login system. أحياناً أنا عندي many systems and if the attacker get even in the maintenance system, right, I'll log in that I don't want. احيانا sometimes انه I also worry about denial of service. ايش الاتاكر ممكن يسوي؟ ممكن ياخذ every email وانا اقول بعد 3 مرات تسوي اكونت لوجن، ياخذ الايميل الاول يجرب الباسورد 3 مرات لوجن، الايميل الثاني باسورد 3 مرات، خلاص اي يوزر يجي تلوجن يقول له لا سوري معليش your account has been locked لانه you've tried the password 3 times. يقول لك يا اخي I did not try the password 3 times. But the attacker is trying to create denial of service attack and he's trying every possible password and trying to log in 3 times. There is another question. Are we trying to protect users from each other? يعني مثال الاتسي password. If one of the users is bad, he might steal this file. عشان كده احنا we put it in the Etsy shadow. Can I train the users? Can I sit down with them أعطيهم courses وكذا وما أدري إيش؟ وإذا if I train them هل بيسمعون؟ Okay? So I might train them in a new system, 2-factor authentication, USB, tons of things. هل الباسورد هذا اللي بيستخدمونها اليوزرز will be used in other systems? Why would I care? أنا ممكن my system is perfect security مرة ممتاز، لكن the user uses this password in another system, that system get hacked، فيها اليوزر نيم and password ياخذها and come and log into my system. هل الباسورد will be used in a controlled environment؟ هل مثلا اليوزر can only log in في داخل المبنى من الماشينز اللي موجودة ديسكتوبس في المبنى؟ If he uses his phone or his laptops, it doesn't matter. فمعناها إنه someone, even if the password is 1 2 3 4 5 6, for someone to succeed لازم يجي ويتعدى السكيورتي حق المبنى ويدخل جوا to be able to log in. So there are multiple things that I need to ask. What am I trying to protect against? What is the problem that I'm trying to solve? بعد ما تكلمنا عن الباسوردز بنتكلم شوية عن البايومتريكس. So البايومتريكس تكلمنا عنها شوية إنه something you are. وتعريف كلمة بايومتريكس is bios معناها من الحياة، مترون معناها مجر، يعني بقيس شيء حيوي. البايومتريكس الفرق بينها عن الباسورد إنه ما في شيء اسمه، يعني الباسورد أنت you put your username and then you put your password or one-time pad or whatever. Yeah, either you have it 100% صح، إذا واحدة كلمة متغيرة أقول لك لا غلط مع السلامة. Biometrics are probabilistic لأنه حتى أنا الفينجر برنت حقتك ممكن إنها غلط، ممكن ما أدري إيش، ممكن يوم معرق شايل حجر طالع بر ما أدري إيش كذا، ف things change and change all the time. ف I cannot ask for a perfect match. الزاوية اللي صورت عليها الكذا المدري إيش يعني في جوانب كثيرة، فأنا لازم أسوي probabilistic measure. بمعنى أجي أقول إذا في تشابه بنسبة مثلا 95% ممتاز، 99% أو 99.9 أو 80% whatever it is، لازم أحدد الخيار هذا. والخيار هذا بيفرق معي إنه أحيانا ممكن اليوزر هو نفسه، بس لأنه مثلا كان تو طالع من المسبح قاعد 3 ساعات الفينجر برنت ما بواضح. Right? So I would reject him even though he's the right person because I asked مثلا for 99.9. So it's always a probabilistic measure that I need to think about. دائما عشان استخدم شيء انه يكون useful for biometrics يحتاج 7 اشياء ومواصفات اساسيه. الاولى it's stable, it's persistent، بمعنى ما تغير. البايومتريكس حقت يدك المفروض انها ما تغير سنه سنتين 10 20 30 40 سنه، it should be always the same. الشيء الثاني it should be distinct, it should be unique، بمعنى انه المفترض انت واخوك انت وولدك انت كذا it should be different between people حتى لو انتم توأم. Even if you're twins your biometrics should be different. And it should be universal، بمعنى أي واحد في العالم المفروض عنده biometrics، إلا إذا مثلا إصبعه مقطوع، أوكي إذا إصبعك مقطوع ممكن إنه أصابعك الثانية. Right? But it should be universal. Every person should have this، أو على الأقل universal في اليوزرز حقينك. إذا أنت مثلا تستهدف اليوزرز في الجامعة أو اليوزرز in your company أو اليوزرز في دولة أو اليوزرز في العالم. It depends what is your target set of users and individuals are. It should be detectable and collectible بمعنى مرة easy to scan it, مرة easy to collect it. البايومتركس before the iPhone كان مرة صعب، لازم جهاز تسلك USBs وما ادري ايش، او تجي في المطارات او and now it became a lot more easier. The cameras now بالphone can capture your face in a lot way easier fashion. So it should be easy to collect. اليوم إذا أنا باخذ DNA حقك، لا لازم تروح المستشفى and then a needle and a specialized nurse يسحب الدم وgo or not necessarily دم، أو لازم أسوي swab بالفم وما أدري إيش to do the DNA. Not anyone can do it. It should be fraud resistance بمعنى أنت ما تقدر بكل سهولة تغير البايومتريك حقتك other biometric. It shouldn't be that easy. It should be acceptable. Acceptable بمعنى اليوزرز ما عندهم مشكلة إنه you take their biometrics. اليوم ما في أحد عنده مشكلة إنك تاخذ البصمة، ما في أحد مشكلة إنك تاخذ الوجه. لكن إذا بتجي تقول عطني your DNA أو عطني your retina scan اللي هو خلفية عينك، بيقول لك why? It should have acceptable performance بمعنى I should be able very quickly to know the result. The DNA is really accurate, but it takes some time, a couple of hours, sometimes a couple of days to do the DNA and check it. So you need to have those 7 things to have a proper choice of biometric. عندنا many biometrics that exist. You know, we have fingerprints, eye biometrics, either البؤبؤ حق العين اللي هو البارز او الشبكيه الخلفيه حقت العين. الفيس biometrics مثل what we see in the iPhones, either 2D or 3D. الهاند geometry بمعنى شكل يدك من فوق, right? Like دائما تشوفون احيانا في بعض المحلات تدخل يدك كذا في اماكن تحط اصابعك لانه يبغى يصور يدك من فوق. السيجنتشر كان بي biometric, احيانا ضغطك القلم، ميلان القلم، السرعه، الحركه، الميلان، كل التفاصيل هذه كان بي this. فويس الصوت، صوتك متغير، صوتك مختلف، اعطيك جمله معينه وتقول الجمله هذه it could be your biometrics. في اشياء ما زالت في مراحل التجربه، مثلا في يدك توزيع عروق اليد، او لو تفتح كف يدك من جوا توزيع الشطوب اللي في اليد، يعني الاشكال المختلفه والاصابع. احيانا طريقه المشي can be used as a biometric وفيها ريسيرش. احيانا رائحه الجسم، كل شخص جسمه رائحه مختلفه انه can be used biometrics. شكل الاذن من برا او يعني صوره سواء اماميه او صوره من الجانب can be used as biometric. كي ستروك تكلمنا عنها، كيف تكتب، اعطيك جمله تكتبها بالكيبورد، سرعه الضغط، احيانا المسافه بين الاي والدي تاخذ منك 10 اجزاء من الثانيه، في شخص تاخذ منه جزء واحد من الثانيه. الدي ان اي والار ان اي كذلك تكلمنا عنها. A biometric system basically has, excuse me, a biometric system has اول شيء gathering the biometric، ياخذ الداتا، ياخذ الصوره مثل الفينجر برنت، right? ف it takes basically the fingerprint هنا as صوره، من الصوره هذه يسوي signal processing، يطلع البيانات من كذا، لانه هو ما يحفظ الصوره، right? Like ما يحفظ صوره العين، ما يحفظ صوره الفينجر برنت، ما يحفظ صوره الوجه. Actually use a mathematical representation of this and save it in some storage. When you log in, right, basically it takes the data again، يطلع منها mathematical representation and then it checks، يقول لك اوكي انا عندي كل storage هذا، وش انت احيانا تقدر تقول له انا مثلا this is my username ABC، فهو يروح يشوف ABC and ايش mathematical representation. If this is verification مثل ما تكلمنا قبل، if this is identification لا لازم يشيك الداتابيس كامل. and then بعدين بيطلع عندي سكور، يقول لك هذه فيها تشابه بنسبة 99%، 20%، whatever. your system لازم يقول أنا إيش الحد الأعلى عندي للقبول. هل الحد الأعلى عندي للقبول 90 99 80 85 20 10 whatever it is. بعدين يقول لك خلاص مقبول and it gives you the decision مقبول أو غير مقبول. ودائما بيطلع عندنا مثل ما قلنا نوعين. إذا أنت رافع الحد الأعلى مرة عالي فأحيانا في normal users you will reject them. إذا الحد الأدنى مرة منخفض في ناس في اختلاف كبير بين مثلا الفينجر برنت حقته والفينجر برنت المخزنة فبيقول لك وأنت قبلته you said yes and you ended up إنه no this is not the right person. فإذا رفعت الحد الأدنى فترد ناس لكن إنك أي واحد بترد ناس حقيقيين لكن بتصعب من المنتحلين إنهم يقدرون. إذا قللت حد القبول بتقبل ناس حقيقيين أكثر لكن كذلك تبي تدخل ناس قد يكونون منتحلين شخصيا. آخر شيء إنه there are always attacks on biometrics. So the gummy finger by Matsumoto, يعني you can see إنه this layer they managed to print some fingerprints وحطها هنا اليوزر يقدر يحطها and create some sort of fake fingerprints. وكذلك أول ما طلعت أبل الفيس recognition في جروب ريسيرش كوري created this fake face of some person and it showed it to the iPhone and then the iPhone accepted that person as the normal user and then there's a YouTube تقدرون تروحون تشوفون the experiments in details. بنوقف هنا في الكلاس for this lecture.